A complex fraction is a fraction that contains fractions within it. I provided an example of one on the page that you see. If we want to simplify this, there are several ways of going about it, but I'm going to show you one method that I like that works very quickly. It's a method in which we find the least common denominator of all of the denominators. If you notice that we have denominators of, if I rewrite 4 as 4 over 1 and 3 as 3 over 1, we have denominators of 1, x, 1, and x squared. The least common of all these is x squared. So what I want to do is multiply the numerator and denominator both by x squared, which means I'm multiplying the fraction by 1, and which is legal. I don't change the value of the fraction, just the looks of the fraction. But if I multiply the numerator by x squared, I would then distribute it throughout each term in the numerator. And if I multiply the denominator by x squared, I can distribute it by each term in the denominator. So in effect, again, I'm multiplying the numerator by x squared and the denominator by x squared. I just distributed it already. Simplify each fraction. 4x squared over 1 is 4x squared. The 2x squared over x reduces down to 2x. 3x squared over 1 is 3x squared. And the x squareds cancel for the last term in the denominator to give us just minus 5. In one step, we basically reduced our complex fraction down to a simple fraction. I can then factor numerator and or denominator to see if this fraction can be reduced any further. In this case, I can factor 2x out of the numerator to get 2x plus 1 over 3x squared minus 5, but the factoring really didn't help us any as far as canceling down any further, so either of these answers would have been okay for the simple fraction. Let's look at a second example. 6 over x plus 5 plus 3 over x minus 3 over 2 over x squared plus 2x minus 15. We have a complex fraction. The denominators are x plus 5, x minus 3, and x squared plus 2x minus 15. In order to find the least common denominator, I want to factor this denominator in the denominator so I can see what it's made up of. So in the denominator of the denominator, I can factor that to x plus 5, x minus 3. And now looking at all of the denominators, I have x plus 5, x minus 3, and a combination of x plus 5, x minus 3, which means that must be my least common denominator. So let's multiply the numerator and denominator by the least common denominator, and I'll write it out as distributing it throughout the numerator and denominator. So I'm multiplying x plus 5, x minus 3 times each term in the numerator and the denominator. Notice that the x plus 5's cancel in this first fraction, and I'm left with 6 times x minus 3. The x minus 3's cancel in the second fraction. I'm left with 3 times x plus 5. And in the denominator, the x plus 5's cancel, the x minus 3's cancel. I'm left just with 2. And again, in one step, we've reduced down our complex fraction to a simple fraction. If I distribute 6 throughout the first set of parentheses, and 3 throughout the second set of parentheses, and simplify 9x minus 3 all over 2. I can factor 3 out of the numerator to see if anything will cancel with something in the denominator, which it doesn't. So again, either of these forms would be okay for my simple fraction. Let me give you a practice problem. Simplify this complex fraction down to a simple fraction using the technique I showed you. Pause the video and come back when you want to check your answer. Notice that this first fraction, the denominator can be factored into x plus 4x minus 4. And looking at all of the denominators, it looks like x plus 4x minus 4 is the least common denominator. So let's multiply x plus 4x minus 4 by the numerator and by the denominator of the main fraction. I'll write it out by distributing it, x plus 4, x minus 4. Throughout the numerator and denominator. In the numerator, the first fraction, the x plus 4's cancel, x minus 4's cancel, I'm left with x plus 2. In the second fraction, the x minus 4's cancel, I'm left with x times x plus 4. And in the denominator, the x plus 4's cancel, I'm left with 4 times x minus 4. Simplifying further, I have x plus 2 plus distributing the x for x squared plus 4x. In the denominator, 4x minus 16. If I combine like terms, I have x squared plus 5x plus 2 over 4x minus 16. If I factored this denominator back down again, I would get the 4 times x minus 4, but since the numerator doesn't factor down any, I can't cancel any factors down any further, so I have a simplified version of the answer at this point. Like I said, there are several methods of simplifying complex fractions, but this is a method that I really like because we're basically multiplying the numerator and denominator by the same value, so we're multiplying by 1. I'm just showing it as distributing that value throughout the numerator and denominator, canceling down, and in one step we have a simple fraction. And then we just have to simplify from there if there's any more simplification.